Hello guys, welcome to the new video again. In this video, we discuss six categories of constraints of permutations. So, this first category is sometimes question could be like that, starting with or ending with, or not starting with or not ending with. So, let's say start. First type is starting with something, some letter or character, ending with and not starting with etc. Right. Second is containing. Second type is containing. Contains. Right. Like 5 letter word contains at least one A, or we can say exactly uh, one A, two A, or etc. Or at most two A, like that. Right? Containing. Third is together with. Right. Third type is together with. Together with is like this. This is a word Mississippi, right? So we can say all S's are together, right? We can say all I's are together, like that, all right? Next is 4 number is uh, no two objects together. Fourth type is no two objects together. For example, no two S's together, right? Or we can say no two eyes. This is the case. Okay? Number 5 is at least alternating arrangements. Alright? Alternating arrangements. In this, what we do is boy, girl, let's say alternating first boy, then girl, then boy, then girl, like that. Right? Alternating. Let's say other is man, woman, like that. Right? And last one is circular permutation. Right? So we will discuss them one by one. Alright. So first is first type is starting with or ending with. Alright. So question is here is how many 4 digit number possible? How many 4 digit number possible. So this is the case. Uh, oh, we have digits from 0 to 9. We have 10 digits. Alright. So 1, 2, 3, and 4. This has how many options? Only 1 to 9. Alright. This has 0 to 9. This also has 0 to 9. And this has 0 to 1. So this has 9 options, then 10 and 10. It would be 9 into 10 to power 3 possible numbers. Right? So if we say, so here note, uh, you can say by default, by default there is unlimited repetition. Alright. And let's say question for me is here that question is, let's say 4-digit even number. Right? 4-digit even number. So what we can say here, there are 4 digits. This has options 1 to 9. Alright. Even number are which ends with 2, 0, 2, 4, 6, 8. Alright. The 5 options are laid here. Okay. You can choose 5 uh, things. Here is all 10 in all 10. So 9 into 100 into 5. 4500 is the answer here. Alright. But if we are saying, if we modify here something, if we say, if without repetition, then what we will do is, there is no repetition. Alright. So there are 4 digits, 1, 2, 3, and 4. Alright. So what we can do is here, uh, there are so many cases here. Alright. It has 1 to 9 options. Alright. Without repetition, no repetition. Alright. It has 0 to 9, it has 0 to 9, and it has 0 to 9. But we, we only need we only need some even numbers only. So this restricts us for 0, 2, 4, 6, and 8 options. Alright. These are the only choices. 5 choices are here. But here is no repetition. Alright. So if we fix this, uh, let's say 1 here. Alright. 1, there is no repetition. For 1 here, we say there are, and we select here any any one of them. Let's say 0. Alright. So how many choices we have left with is 8 and 7. Alright. And for this only, we have 5 choices here for this: 0, 2, 4, 6, and 8. For this case only. Alright. So what can we do is, 1 is here, but 8 and 7 and 5. So for this, how many starting with 1 is 8 into 7 into 5 numbers. But if we say it start with 2 here, so we have left choice with choices only 0, 4, 6 and 8. Alright. So 2 is here and for one of them from it here on 8 and 7 are also, but right, but we are left with what? Uh, we are left with 4 choices only. So this is 4 choices. This is 7 choices. This is 8 choices. This is 1 choice. It is 8 into 7 into 4. So there is a pattern here. When starting with even number, starting with even number, so it has 8 into 7 into 4, and starting with odd number, it has 8 into 7 into 5. Alright. So, but how many odd numbers we have? Options. We have 1, 3, 5, 7 and 9 for first place. So we have 5. So we can multiply 5 times this. No, no, no. This is not. This is odd. Alright. So 5 is here. Alright. And but for odd, we have options only 2. We go first place for 4-digit number. 2, 4, 6 and 8. So 4 times. So it would be answer is 4 into 8 into 7 into 4 plus 5 into 8 into 7 into 5. So this is the total number of total 4-digit numbers possible. Total 4-digit even numbers possible without repetition. Right? For this question, we have second method also here, guys. So let's discuss this second method also. Change the color for this only. We go this. No. Can we go this? Alright, this is good. Super. So what was the question? Question was question was it's hanging, bro. It's hanging. Right. So guys, let's discuss the question. What was the question? Question was 4-digit even number possible without repetition. Alright. So what can we do is even numbers are what? Ending with 0, ending with 2, ending with 4, ending with 6, and ending with 8. These are ending with. Alright. So we have to add them, ending with 0 plus ending with 2 plus 6 plus ending with 8. There are 4 things. Alright. Now we are left with 1 to 9 digits. Alright. Here, for in this case, 1 to 9. How many choices are we have left here? 9. How many choices we left here? 8. How many choices we left here? 7. This is the answer. In this case, we have choices 0, 1, not 2, 3, 4, and 9. Right? How many choices are there? 9 choices. But for the first place, how many choices we have? Only 8. 8 choices. Alright. And for rest of the because we can't use 0 here. For rest of the places, we have choices uh, including 0. We can't include 0 here. So wait a minute. Oh, yeah. Now we can use 8 choices we left also, and then 7, and so for these also. All right. So 8, 8 and 7, 8, 8 and 7, 8, 8 and 7. So into uh, right, right. So how many choices we have here? One only. One, 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 and one. So answer would be like it would be like we can get common 8 into 7 here, and how many left are 9, 8, 32 plus 9 is 41, and it would be like 56 into 41 is equal to what? Anything you would say, and this is the answer only. I hope you understand this question. This was a very important question and very tricky also. Uh, Second concept we will learn about is next concept. When we select first digit from the number first, then dependency also remain last digit in method 1. But in method 2, when we fix digit at last, there is no dependency, hence this method is fast. Yeah, this method is about fast only. We know, right? Fix at last, fix at. Second category. Second category of permutation constraints. Wait a minute. Right. Category 2. So, 5-letter word uh, contain exactly 1A. Okay. So what is the 5-letter word contain exactly 1A. So what we do here is, there are 5 letters, 2, 3, 4 and 5. Right? 1A. Right? A could be here, 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 here or here. If A is here, alright. So what rest of exactly 1. So what were the rest of the numbers? 25, 25, 25, 25 and 25. Alright. It would be 25 to the power 4. This can be repeated for 5 times. Alright. So it would be 5 into 25 to the power 5, 4. Alright. But what we can do also here, what we can do is, there are 5 places. Second method is, there are 5 places here, 5 places here for A. We can select any of them to set A. So 5C1, select 1, right? And rest of 4 is for other things into 25 letters to the 4. It would be like that only, alright? But if we modify this question only for if exactly 3 is, here is unlimited repetition, alright? Unlimited repetition. Keep in mind here. So exactly 3 is like, there are 5 places. We have to put 3 of them. Select 3 places to put A. So what we can do, because A's are identical, alright? So it would be like 5C3. If A were not identical, it would be like 5P3, right? Permutation. So A are identical, then this is 5C3 only. Then 5C3 into 3 are there. For rest of this is 25 into 25, right? This is how we do it. Next question or type of question is, next is at least 1A. At least 1A. So there are 5 places here, 1, 2, 3, 4 and 5. At least 1A means uh, we can say total minus 0A, right? Total would be like 25 to the power 5, 26 to the power 5 minus 0A be like 25 to the power 5. This is, this would be like at least 1A, alright? Complement method. This is called complement method, alright? Next type of question is at most 1A. At most 1. It will be like, wait a minute, 1, 2, 3, 4 and 5. There are 5 places here. What we are doing here is, at most 1 is equivalent to exactly 0A plus exactly 1A. And exactly 0 is would be like 25 to the power 5 plus exactly 1a we like 5c1 and 2. We could do this previously. 5c1 into 25 to the power 4, right? This is the answer here. Hope you understood. And next is contain exactly. So how many 5-digit numbers contain exactly 1 7? Alright. This is the type of question we can solve in this. How many 5-digit number? 5 digits, there are 5 digits only. 4 and 5. Right. And what we can do is exactly 1. Right. So 5c1 is there only. Right. 5c1 is here. Right. But first place has options. How many? 1 to 9. This is 0 to 9. This is 0 to 9. 0 to 9 and 0 to 9. Right. 7 could be anywhere. So 5c1 is the option. But for rest of it is uh, wait. There is a trick here. Alright. So let's say alright. If 1 to 9, 0 to 9, 0 to 9, 0 to 9 and 0 to 9. When it has 7 here, alright. 7, we cannot use what? We cannot use 0, alright, and 7. So how many options we left with here is 8 only. 8, then is it 8 or is it 9? 7, 2 are there. 8, then 7, 6 and 5. Alright. Is it 8, 8, 8, 8? Alright. No, this is not how we do. When we are starting with here is with 7. Alright. So how many choices we left here is? Alright. Uh, choices are 9, 9, 9 and 9. Alright. This is one choice. But when we are, but we are exactly 1 7 here only. So right, we are not using 7 here, so 9 digits are left. Alright. But if we have 7 is not, so 0 is not here, right? And 7 are other places. So how many are there is 8, right? And what we are doing here, there are 4 places for 7. This is 4c1, and rest of it for the 3 times is 0 9 to the power 3, right? This is how, plus 9 to the power 4. This is how we do it. 4c1 into 9 to the power 3, right? 8 also. 8 we forgot here is uh, 8 also, because 8 options are we have here. And 8 into 4c1 into 8 into 9 to the power 3 plus 9 to the power 4. This is the answer, right? That's how we do it. And next question is exactly 2 sevens. Alright. So what is the answer for this? Let's do this. Exactly 2 sevens. There are 5 digits here. 1, 2, 3, 4, and 5. Alright. What we are doing here is, if 7 is here, right? 7 is starting with 7. Alright. Starting with 7. 0 can't be here. So how many choices we left with here in second place? Uh, because we can choose for 1 7 also. So for 1 7 we can choose from here only. So 4C1 is that, right? Into for leftover is uh, 3 places. Let's say 7 one of them, and how many digits we have? 9 here. So 9 to the power 3, right? This is one only, right? But when we are not starting with 7, so we have only we can start with 0 and 7. We have 8 choices here only, and for rest of it we have 4 C2 places for 7, placing 7, and rest of it is for 9 to the power 2 is for rest of the digits, right? 4 C2 9 to the power 2. And what is this like? Is this correct? So it is into 8 also. Yeah, we can add them, and this is the answer only, right? Category 3. Category 3. Category 3 is together with. What is this like? First question we solved for this category is, let's say equation is the word, equation, and this is saying all vowels are together. What is the permutation for this? So vowels are A here, E, U, I, A, E, I, O also, O, U, and rest of it is T and Q and N only, right? So how many vowels are there? There are 5. So we can interchange them as 1. 5 factorial is 1. And we can put these 5 factorial in how many places? 1, 2, 3, and 4. 4 places. So into 4, C1. And we can interchange these also into 3 factorial. So we have to uh, it would be like 5 factorial into 4 into 3 factorial. It would be like 5 factorial into 4 factorial, right? And second method is here is let's say A, E, I, O, U are five, only one word, and T is second word, right? T, Q is third, and N is fourth. What we can do is here, there are total how many words? 4 words. 4 factorial. 1, 2, 3, 4. But internally this is only also a word. So this is 5 factorial. This is the answer for second method. Right. Next question for this will be, question is, all vowels are not together. This is an important and tricky question here. Like all vowels are not together. So what they are saying is A, E, I, O and U, Q, T and N. This is the letter we have. All vowels are not together. So what we can do is here total permutation minus all vowel together permutation. All 5 3 8 factorial minus 5 factorial into 4 factorial. Is this good? Yeah, this is the answer. Complement that. We say it as complement method. Right? Next would be like, next word is Mississippi. Uh, so all S's are together. So in this we are what we are doing. All S's are together. So all S's are together is S, S, S and S. Right? This is one word. M, I, P, P, I. This is left over. So for this is one word. S is one only. We are not doing it either ways. So one we will count it as 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 letters and with limited repetition, 8 factorial upon. This is 1 factorial, this is 4 factorial and 2 factorial. This is the answer. Right? But if we can say all S's, all I's and all P's are together, then answer would be like, let's say S make 1, all I are 1, all P are 1, all M is 1. A 4 size, 4 factorial and not repetition. This is 4 factorial answer. No two objects of certain type together. So next type of this is category 4. Category 4 is saying no two objects of certain type together. No two objects of what we can do for this is, let's say equation. Equation is the word. And no two consonants together. And this is asking no two consonants are together. So A, E, I, O, U and Q, T and N. These are consonants. Alright. So what we can do is Q is here, T is here, N is here. There are places for vowels to settle. Alright. And this is how many places are there? 1, 2, 3 and 4. 4 places and 5 vowels. How many types we can they can sit here is it 5? No, because this is permutation here. This all are distinct and does not repeat themselves. Unlimited repetition, is it? No. Uh, 4 are there, 5 are there. So we have to put them in how many places? Let's say there are uh, without repetition, is it? It would be like 5P4, right? And 5P4 and 3 factorial, right? So what it would be like? And 5 factorial also. Is it answer for 6 factorial upon 3 factorial? 6, 5 into 4, 5 factorial upon thing. 5 factorial into 3 factorial. Which is about, I'm not understanding this here. What is going on? But no two consonants are together. So this is A, E, I, O. This is not the way we can do this, right? So what we will do is we will do A, E, I, O, and U. And how many places are now? 1, 2, 3, 4, 5, and 6. For how many consonants? 3 consonants. All right. So we can choose them these 3 places for 3 consonants. All right. It would be like 6C3, and this consonant can also interchange with themselves 3 factorial. It will become 6P3. All right. But this is not the right way. This is the right way. And consonants also, vowels also move, interchange with each other. This is the answer. Right. Now I understand. Next question is All right, I think we will discuss this in next lecture. No, in this lecture only. Next category in the next lecture. Some more question in this category. Example: no two vowels together. No two vowels together. This is Q, T, N, Q, T, and N. How many places are there? One, two, three, four only. But how many vowels we have? Five. So this is not possible. Not possible. Right. Next is, let's say Mississippi is the bird, and this is saying no two S's together. So what we can do is one M I I P P. 1 2 3 4 5 6 7 8. 1 2 3 4 5 6 7 8 places are there for 4. So 8C 4 only. 8C 4, but they cannot interchange with each other because they are identical, right? And these can be permutation. How many places? 1 2 3 4 5 6 7. 7 factorial upon how they can repeat also 4 factorial and 2 factorial, right? So this is the answer only. Next question is number of zeros, let's say n, and number of ones, let's say n, then how many way to arrange such number 2 1 is together, such as number 2 1 is, how many ways to arrange such that no two ones are together, right? So, how many zeros are we have? One, two, three, four. Let's say this. Let's say this, right? And one we have n. So, what we can do is, how many places we have? One, two, four, five. M plus one factorial. M plus one places we can for n, right? One, 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 and one. And this is the one way, right? Second way is 0 1 0 1 0 1, right? And third way is 1 0 1 0 1 0. Three ways only. Yeah, this is only m plus 1 cm. This is how we do. M plus 1 places and select these places. M plus 1 cm only. This is a very important question, and Thank you so much for watching this video, guys, and we will meet you in the next one. Bye bye.